Okay, so we're going to do 8 problems today, but the first 3 are going to be repeats. So 1 is going to be the same as 2, 3 is going to be the same as 4, and 5 is going to be the same as 6. And the reason why I'm doing that is because we're not only going to do this find the solution set using factoring, but we're also going to use find the solution set using the quadratic formula. And then I'm going to put my tips at the end of this video. Okay, so first things first, we're trying to solve for x. 3x squared plus 16x plus 20 is equal to 0. Notice that the a is equal to something other than 1. So a is not equal to 1. And I can't exactly divide everything by 3 because that's the only factor I can think of. Even number, no, that doesn't really do anything. So I have to use label A, B, and C. And we're going to factor. So in this case, since A is not equal to 1, we have to use this technique of what two numbers multiply to AC and add to B. So in this case, the AC is 3 times 20, that is positive 60. And the B is positive 16. So we're looking for two numbers that multiply to 60 and add to 16. Can you think of what they are? Okay, pause the video if you want to figure this out on your own. Okay, so that winning combination needs to be a positive times a positive. In particular, positive 6 times positive 10, they multiply to 60 and they add to 16. So what that does is this now splits 3x squared plus 16x plus 20. We're going to split this into positive 6x and positive 10x. Excuse me, I need a glass of water. Okay? There we go. All right, so now this becomes positive 3x squared plus 6x plus 10x plus 20, and now we're going to split it. Now we're going to factor by rectangle. So now we're going to put the pieces in and we're going to factor accordingly. So we're going to put ax squared in the top left, we're going to put the c in the bottom right, and let's put the positive 6x here and the positive 10x over here. Okay, so now let's factor the pieces out. I'm going to cover up this right column and let's factor. 3x squared and positive 6x can both factor out a 3x. 3x times 1x is 3x squared. 3x times positive 2 is positive 6x. And x times 10 would be positive 10x. Check my work. Positive 10 times positive 2 is positive 20. So this is what it factors into. So now I've got x plus 2 times 3x plus 10 is equal to 0. Now I've got the zero product principle because I've got a multiplication problem and the output is equal to 0. So let's split this up into two cases. Either x plus 2 is equal to 0 or 3x plus 10 is equal to 0. So let's solve for x. So now I'm going to start with the left side. So I'm going to subtract 2 from both sides. Oh, what do you know? X is equal to negative 2 is one of the solutions, but that's not the entire solution set. I'm looking for all the values of x that make this statement true. So now let's do 3x plus 10 is equal to 0. Let's subtract 10 from both sides. So now I've got 3x is equal to negative 10. And then I'm going to divide both sides of the equation by 3, getting me x is equal to negative 10 thirds. If you want to leave this as a decimal, that'd be negative 3.333333. I would leave it like this. So in order to solve this, by factoring, you would need to split the middle term, put them in the rectangle, and use the zero product principle. Now that we know the answers are negative 2 or negative 10 thirds, let's try this using the quadratic formula. Okay, So so 3x squared plus 16x plus 20 is equal to 0. If factoring is too hard, there's another way, the quadratic formula. So what we do, yet again, is we label our a equals 3, our b is equal to 16, and our c is equal to 20. 20, there we go, not 10, 20. Okay, so now let's put the pieces in. The quadratic formula states that in order to solve ax squared plus bx plus c is equal to 0, then the x-intercepts can be found by plugging in negative b plus or minus the square root of b squared minus 4ac, all that over 2a. So let's plug in b, negative 16, plus or minus the square root of 16 squared minus 4 times a, this time a is 3, times c, which is positive 20. All that over 2a, a is 3. So I'm going to need a calculator. All right, so let's clean this up a little bit. This is just negative 16, so I'm going to put a negative 16. Plus or minus the square root of 16 squared. So I'm going to plug in whatever the calculator says for 16 squared, because I don't know that off the top of my head. I believe it is, yes, I was right in my head, 256. Okay. And then I'm going to do negative 4 times 3 times 20. So that would be negative 240. Okay. All that over 2 times 3, which is 6. All right, so now let's plug it in some more. Negative 16 plus or minus the square root of 256 minus 240, that would be 16 over 6. And what I'm going to pay attention to in particular is the discriminant. So the discriminant, b squared minus 4ac, is positive. So what that means is that there are two real solutions. Okay, so now we just evaluate what the square root of 16 is. In this case, we're going to plug in negative 16 plus or minus the square root of 16, which is 4, all that over 6. Now that we know that there are two real solutions because of the discriminant, let's split this into two separate cases. So x1 is equal to negative 16 plus 4 over 6, because of the plus part. It's two separate equations. Or x2 is equal to negative 16 minus 4 over 6. So now let's simplify this left part. So x1 is equal to negative 16 plus 4, which is negative 12 over 6. Negative 12 divided by 6, x1 is equal to negative 2. So one of the solutions is x equals negative 2. Now let's look at the other one. x2 is equal to, that'd be negative 20 on top, over 6. And I suppose I can reduce this into negative 10 thirds, or yeah, you could divide it and you would get negative 3.333333. But either way, it's the exact same solution set as the previous problem. Yep, doesn't matter. Okay, let me just scan this really quick. Okay, moving on to the next problem. Number 3, 5x squared minus 14x plus 8 is equal to 0. Let's do this using factoring. So once again, my first move is, well, I don't like a is equal to 1. Let's see if I can divide something from 5, 14, and 8. I'm not happy. So what I do is I label my a is 5, my b is negative 14, and my c is 8. So I need to figure out the winning combination. If I want to do this with factoring, what two numbers multiply to AC and add to B? So A times C is positive 40, and add to B, that'd be negative 14. So if you want to figure out this winning combination, What two numbers multiply to positive 40 and add to negative 14? If you want to do this on your own, you can pause the video, because I'm going to give the solution in 3, 2, 1. Okay, so it has to be a negative times a negative. In particular, that negative-negative combination would be negative 4, negative 10. Negative 4 times negative 10 is positive 40. Negative 4 plus negative 10 is negative 14. We have a winner. So what this does is this takes the trinomial 5x squared minus 14x plus 8, and I'm going to split the middle term. What this does is this takes the negative 14x, takes it into negative 4x, and negative 10x. Okay. Now I'm going to put it into a big rectangle. So the ax squared on top is going to be 5x squared. On the bottom right is going to be the 8. That's the c. And it doesn't matter which of these two go where. So I'm going to put negative 4x here and negative 10x up on the top right. So now let's factor the pieces out. What can I factor out of 5x squared and negative 4x? Well, 5 and 4 can't divide anything except for 1, so that doesn't really help me. But I know that I can factor out an x because x squared and x share an x that I can factor out. Now, 1x times what is 5x squared? 5x. X times what is negative 4x? Negative 4. Check my, 5x times what is negative 10x? That would be negative 2. Check my work. Negative 4 times negative 2 would be positive 8. That would be correct. So now I've got all the information I need. I'm going to factor this into 5x minus 4 times x minus 2. Oh, sorry. So now I've got 5x minus 4 times x minus 2 is equal to 0. Let me make that 4 a little bit cleaner. There we go. So now I have the multiplication problem. I'm going to break this up using the zero product principle, the most important thing that'll get you into Algebra 2. Factoring and zero product principle, it's good to get practice with this. So in particular, I've got 5x minus 4 equals 0, or x minus 2 is equal to 0. Well, I'm going to start with the right side since it's much easier. X minus 2 equals 0. I'm going to add 2 on both sides, and that gets me x is equal to positive 2. Okay? Now, I'm going to look at the other side, the left side. I'm going to add 4 on both sides. That gets me 5x equals 4. 5x equals 4. We divide both sides by 5, and in particular we get x equals 4/5. Now if you like decimals like I do, you can do 4 divided by 5 and get x equals 0.8. Either way, I'm very, very happy, but this is the same number. So either x is equal to 0.8 or x is equal to positive 2. Right? So what if that was too hard for you? I agree. We can always use the quadratic formula because for some reason I like the quadratic formula. It's the end all be all. So in particular, you plug in a equals 5, b equals negative 14, and c is equal to 8 into this monstrosity. Remember, negative b plus or minus the square root of b squared minus 4ac, all that over 2a. And we're going to plug in a, b, and c. So we're going to look at b. b is negative 14, so even though there's a negative in front, I'm going to put negative blank, and I'm going to fill that blank with negative 14. So negative b plus or minus the square root of b squared, that b is negative 14 still, minus 4 times a, which is 5, times c, which is positive 8. All that over 2 times a, which is 5. Well, now, let's clean this up a little bit. So we look at this, we've got negative 14. Well, a double negative can form a positive. So this is positive 14 plus or minus the square root of negative 14 squared. So I go parentheses, negative 14 and parentheses, quantity squared. That'd be positive 196. Okay. Negative 4 times 5 times 8, that'd be negative 4 times 5 would be negative 20, times 8 would be negative 160, I'm pretty sure. I mean, negative 160, exactly. So minus 160, all that over 2 times 5, which is 10. So 14 plus or minus the square root of 196 minus 160, all that over 10. So now let's clean this up. 14 plus or minus the square root of, that would be 196 minus 60, that'd be positive 36 over 10. So, once again, I care about this result. Remember that the b squared minus 4ac is positive. So if the discriminant is positive, that means that there are two real solutions. Okay, so now I'm going to take the square root of 14, but we're going to, the square root of 36, rather. And that becomes 14 plus or minus 6 over 10. And now I'm going to split this into two separate equations. In particular, x1 is equal to 14 plus 6 over 10. And x2, which is going to be 14 minus 6 over 10. So now, 14 plus 6 is going to be 20 over 10, and 20 divided by 10 is 2. So that is one of the solutions. The other solution, x2, we're going to do 14 minus 6, that's going to be 8 over 10. I could simplify this fraction and divide the top and bottom by 2 and make it 4 over 5, because all I did was divide the top and bottom by 2, reduce the fraction. You can do that. I personally like a good decimal. 8 divided by 10 in the calculator would be 0.8. It's the same result. You just pick one, fraction or decimal. Hey, aren't these the same exact solutions we got by factoring? Yeah, they are. And this is what we did with the quadratic formula. Okay. All right, number 5. 3x squared plus 10x minus 8 equals 0. Find the solution set. Okay, once again, we're going to do this with factoring first and then the quadratic formula. Let me get a sip of water. I don't know how you guys are doing in this heat wave. Anyway, so once again, a is not equal to 1, which really bums me out. So a is equal to 3, b is equal to 10, and c is equal to negative 8. So I'm going to figure out the winning combination that multiplies to AC and adds to B. So A times C, 3 times negative 8 is negative 24. And add to B, that'd be positive 10. So if you want to pause this and do this on your own, go for it. Otherwise, I'm going to give the answer in 3, 2, 1. Okay, so if it multiplies to negative 24, that has to be a positive times a negative. But if it's a positive times a negative and it adds to a positive, that tells me that the positive needs to be a stronger value. In particular, this winning combination needs to be negative 2 times positive 12. Negative 2 times positive 12 is negative 24, but negative 2 plus 12 would be positive 10. So that is our winning combination specifically. So if A is not equal to 1, what's so special about this winning team? Well, it splits the middle term. So I've got 3x squared plus 10x minus 8, and I'm going to split this middle term, after I write 3x squared and negative 8. I'm going to split this positive 10x into negative 2x and positive 12x. Okay? Once I'm done with that, I'm going to make the rectangle out of this. Okay, so now let's put the pieces in. The ax squared is positive 3x squared. The c is negative 8. And it doesn't matter where the split bx's go. I'm going to put negative 2x here and positive 12x over here. So now let's factor out the pieces. If I cover up the right column, what can I factor out of 3x squared and negative 2x? Can I divide something from 3 and 2 besides 1? I don't think so. I think 1 is the only factor I can divide out of 3 and 2. But they do have an x in common, so that makes me happy. Okay, x times what is 3x squared? Well, 1 times 3 is 3, and x times x is x squared. So x times 3x is 3x squared. Okay, x times what is negative 2x? That would be negative 2. And then 3x times what is positive 12x? Positive 4. Positive 4 times negative 2 is negative 8. That is true. So then I'm going to break this up into a multiplication problem. So one of my factors is 3x minus 2, and the other factor is x plus 4. And we're going to set that equal to 0, and we're going to use the zero product principle. So let's split this up into two separate equations. So either 3x minus 2 is equal to 0, or x plus 4 is equal to 0. Okay, so let's start with the right side since it's a little bit easier to work with. If I want to solve for x, I'm just going to subtract 4 from both sides. And that gets me one of the solutions, which is x equals negative 4. Then I'm going to look at the left equation. 3x minus 2 is equal to 0. So I'm going to add 2 on both sides and get 3x is equal to 2. And now I'm going to solve for x, 3x equals 2, by dividing both sides by 3, because that'll cancel it out, leaving me with x equals 2/3, or if you're a fan of decimals like me, this is going to be x equals 0.66666666666. So I'm going to put a little hat on it to say it is repeating. So either x is equal to negative 4 or 2/3. Okay, 0.6 repeating is the same thing as 2/3. Okay, but what if that was too hard for you? I like the quadratic formula because it's literally, hey, here's this really complicated formula, but if you know your a, b, and c, it's not that bad. A is equal to 3, b is equal to 10, and c is equal to negative 8. 3x squared plus 10x minus 8 is equal to 0. We can find all values of x by this formula. So now we're going to plug in a, b, and c. So negative b, which is, in this case, it's positive 10, so negative positive 10. All right, plus or minus the square root of b squared, which is 10 yet again, minus 4 times a, in this case 3, times c, which is negative 8. All that over 2 times a, which is 3. So negative 10 plus or minus the square root of 10 squared minus 4 times 3 times negative 8. Okay, so now, is this a double negative? Just negative 10? It's just negative 10. Okay. plus or minus the square root of 10 squared, that'd be 100. And then negative 4 times positive 3 times negative 8. Let's use the calculator here. Negative 4 times 3 times negative 8. That'd be positive 96. And then 2 times 3 is 6. So we've got negative 10 plus or minus the square root of 196 over 6. Okay. Well, I'm going to look at the discriminant yet again. In this case, b squared minus 4ac is positive, so that means that there are going to be two real solutions. Okay, so now we need to figure out what the square root of 196 is. So let's make this negative 10 plus or minus the square root of 196 over 6. I could really use the square root of 196 right about now. So that'd be 14. So that'd be negative 10 plus or minus 14 over 6. Well, now that we've got this plus or minus part figured out, let's split this into two x values. Either x1 is equal to negative 10 plus 14 over 6, or x2, which is negative 10 minus 14 over 6. Okay, so now we've got x1 is equal to negative 10 plus 4, which is 4 over 6, or x2, which is negative 10 minus 14, that'd be negative 24 over 6. Okay, so now let's take a look at x1. I suppose I could reduce this fraction by dividing the top and bottom by 2. That would make this 2/3. Hey, what do you know? Or if you just wanted to do 4 divided by 6 in the calculator, you would get 0.666666666. So either one of these is cool. So if you just wanted to do 4 divided by 6 and give me a decimal, I'm happy. If you wanted to reduce this into 2/3, I'm happy as well. But please make sure it's a reduced fraction. Okay, the other one is x2 is equal to negative 10 minus 14 over 6. That'd be negative 24 over 6, or negative 4. And I'm going to check, did we get the same results that we did using the factoring method? Negative 4 or 2/3? Love it. We got it. So just to show you that this was the quadratic formula way of solving 3x squared plus 10x minus 8 is equal to 0. Okay. So I'm going to do one last problem, and there's a reason why I went over the quadratic formula. So we've got 3x squared plus 5x plus 25. Okay, so once again, I'm going to see if I can factor this. So a is equal to 3, b is equal to 5, and c is equal to 25. So in this particular problem, we're looking for two numbers that multiply to ac, 3 times 25, which would be positive 75, and adds to b, which is positive 5. So let's give this a shot. Well, I'm going to try. All right, 1 times 75. 1 times 75 is 75. 1 plus 75 is 76. Okay, divide by 2. Well, 75 is an odd number, so I can't divide by 2 and get a whole number. But I know I can do 3 times 25. 3 times 25 is 75. 3 plus 25 is 28. And finally, the last set of whole numbers I can do is 5 and 15. 5 times 15 is 75. 5 plus 15 is positive 20. And to be quite honest, I've run out of whole numbers. So in this case, if you cannot factor, let's try the quadratic formula. So I'm going to bring up the same problem, 3x squared plus 5x plus 25, but this time I'm going to use the quadratic formula. A equals 3, b equals 5, and c equals 25. So in particular, we're going to do the x-intercepts are equal to negative b plus or minus the square root of b squared minus 4 times a times c, all that over 2 times a. So now, let's plug in negative blank plus or minus the square root of blank squared minus 4 times a times c, blank blank, all that over 2 times blank. Okay, so negative b, which is 5, plus or minus the square root of 5 squared minus 4 times a times c, which is 25, over 2 times a, which is 3. So now let's clean this up. Negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times 3 times 25. So let's do negative 4 times 3 times 25 is equal to negative 300. Okay. All that over 2 times 3, which is positive 6. So now we've got negative 5 plus or minus the square root of negative 275 over 6. So I'm going to pay attention to the discriminant because now I've got the square root already. So what I notice is that b squared minus 4ac is negative, and I cannot take the square root. Sorry, b squared minus 4ac is negative. So the answer to this is that there is none. There is no real solution. That literally is the answer. So if the square root in the discriminant is negative, that's impossible. So it'll never cross the x-axis. So if factoring is too hard, I would recommend the quadratic formula. Which brings me to Matt's tips. So if you want to know my secrets to doing this, honestly, this is how I break it down. So I know I say that factoring is going to get you into Algebra 2, which is true. However, with this unit, I say play smart. So if A is equal to 1, I always like to do the multiply to C and add to B. Right? So if multiply to C, add to B, and then you break it down and then factor. Split into 2 cases, and then solve for x. So if A is equal to 1, try factoring first. Okay? Right? The second tip I can give you is if factoring is too hard, right? Use the quadratic formula. And the reason why I love the quadratic formula is because even though it's long, negative b plus or minus the square root of b squared minus 4ac, all that over 2a, the b squared minus 4ac, this is the spoiler. The discriminant tells you whether the problem can be solved or not. So it tells you how many solutions there are. So first things first, if the b squared minus 4ac is negative, you're done. It's impossible to solve. So my tips are Factoring is always the quickest way to do it, but really factoring is only quick if the leading coefficient is a is equal to 1, x squared plus bx plus c. But if you've got ax squared plus bx plus c is equal to 0, or if factoring is too hard, I would recommend the quadratic formula. In fact, for the next couple videos, I'm going to use the quadratic formula when a is not equal to 1. And I'm going to try to factor if a is equal to 1. That's just my strategy. Quick, strong. Okay. Hope you guys had a great 3-day weekend, and I'll see you guys next time.